make sure we go back to this page, flip your packet over, and let's talk about exponential decay. So we know that this first example here is a decay function. And hopefully in your mind you're saying it's because this parent, that b value is less than 1. So my factor is still what I see here. It's 0.60. But now the question we're going to ask ourselves is how much under 1 is my factor? Okay, I have to be smaller than 1 to be a decay, so how much under am I? And so we can set this up as 0.60 is equal to 1 minus r. So if we try to solve for r, you should find that you get 0.40 or 40%. I'm subtracting essentially 60 from 100, 100%. So again, number 4 here, we know we have a decay because this base, my parent, this b value is less than 1. Okay, that represents a decay. My decay factor is what I see, what's being multiplied, so that's 0.42. And I have to ask myself, all right, how far under 1 is that? So I'm going to take 1 and subtract 0.42 and find that that's 0.58 or 58% under 1. So try this last one again. I encourage you to pause the video for a second. See if you can answer this without my prompts. But you should know that when my parent function, that base is less than 1, I have a decay. My factor is what I see in my problem already, 0.925. And in my calculator, I want to know how far under 1 that is. And we should write 0.075 or 7.5%. Okay? These two things should add up to 1, or if I wrote this as a percentage, they should add up to 100%. So let's flip our packet over and then flip one more page over so we can look at the decay notes. Exponential decay is going to use the same formula. We're still going to have an amount, my principal, my rate, and my time. But since I am decaying, I'm going to subtract my rate now. I want to make sure that my base is under 1. All right, so here, these examples are a little bit different. They want the decay factor. They want what you see here as the base of your function. Remember, the rate of your decay is how far under are we going? And you should put 0.30. That adds up to 100%, so I know I'm 30% away from 100. Remember that your initial value is the number out front. It's in your principal spot, that letter P. And if I want to evaluate for 6, or x for 6, we remember that x is just another measurement of time. And so we're going to think of that as just t equals 6. So we'll have 24 times 0.70, and I'm going to substitute in that 6. So 24 times 0.70 raised to the 6th, I get a final answer of 2.82. Remember, we're going to try to remember to keep going out to 2 decimal places, because more likely than not, we're going to talk about money. All right, let's look at example 2. Again, we already know that this is a decay, so they want the decay factor. That's the base of my function. Well, my rate is how far I am away from 1, and that is 0.77, or 77%. So if I add those two things up, I'm adding to 100. My initial amount is out front. Okay, it's in the principal spot, that P spot. And it's asking me to evaluate at time 4. So what we're going to do is we're just going to substitute. So we'll rewrite our function. And in that T spot, we're going to put in a 4. So 8 times 0.23 raised to the 4. We should get 0.02, and since 0 was my first digit, I'll just go to 3. Once again, I want you to try number 3 by yourself. I want you to try number 3 by yourself. Get some practice with it. So let's move down into some more word problems. A mice population of 25,000, so here's my principal, in the year 2000 is decreasing. That word decreasing tells me that I should be using my decay. And then my rate is 20%. So we're going to write a model. And we're going to have 1 minus to the time. Okay. My initial amount is 25,000, so I'm going to put that up here first. Remember, when we talk about 20%, we should be moving that 2 decimal places to the left. And there's my equation. This equation represents this story about my mice. Well, how many mice will there be in 3 years? Okay. Remember, this represents time. So I'm going to plug in, I'm going to substitute in that 3. So I'm going to have 25,000 times 1 minus 0.20, and I'm going to raise that to the 3. And we get that there are 12,800 mice after 3 years. So let's try number 5. In 2010, we bought a car, and it was worth this much. So that's P. That's my principal. And we drove it off the lot, and it started to depreciate. Depreciate is another key word for us to be using decay. And the rate it's depreciating is 10%. So again, I encourage you, try writing this on your own. Okay, pause it and test yourself. They want us to write this function. I chose my wrong color. Okay, so 1 minus, because I know it's decay. My initial amount, my car was worth $28,000. My rate, I have to be sure that I move that 2 decimal places to the left, so it's 0.10. And I filled in the necessary spots for my template. Well, they want to know what happens in the year 2020. Well, if I start in the year 2010, how much time has passed? We should be writing T equals 10. From 2020 to 2010, that is 10 years that have passed. So we'll substitute that into our calculator. We'll say 28,000 times 1 minus 0.10. And in that T spot, we're now going to put in a 10. And my car is now worth $9,762.99. Okay, 99.6. So technically, if I were to round, this is really $9,763. Okay. So those are decay problems. So I'd encourage you to try a couple more at home, and then you can better find the questions that you want to either ask in tutoring or while we practice in class tomorrow. Okay. If you need to, my recommendation would be to just rewatch the videos one more time. Okay. see where I'm coming up with these formulas and how I'm evaluating them. And we'll practice some word problems tomorrow in class.